Hey guys, let's look over the free fall practice problem worksheet and look at the answers and see if your answers are the same. A ball is dropped from wrist, and A says, how fast is the ball going after 3 seconds? So for your velocity, you're going to have 0 meters per second for your initial velocity. Your time is 3 seconds. Your acceleration is 9.8 meters per second squared, and your final velocity is what you're solving for. So final velocity is going to equal initial velocity plus acceleration times time. So you're going to fill in all your numbers. So you'll have 0 plus, and then parentheses, 9.8 meters per second squared times 3 seconds. You'll multiply those two, add it to 0, and you're going to get your final velocity to be 29.4 meters per second. So B says, how far has the ball fallen in 3 seconds? So you're going to have distance equal your initial velocity times time plus 1/2 the acceleration times time squared. So your 3 seconds are going to be in two spots in this particular area, anywhere there's a T. So you have 0 times 3 seconds plus 1/2 times 9.8 times 3 seconds squared. So you do your math and you get 44.1 meters. Question 2 says platform diving in the Olympic Games takes place at two heights, 5 meters and 10 meters. What is the velocity of the diver entering the water from each platform if he steps off the platform initially? And so they give you the problem and the calculation. So you use 5 meters, you get 9.9 meters per second. And then if you use 10 meters, you're going to get your 14 meters per second. So question 3 says a model rocket is launched straight upward at 58.8 meters per second. How long does it take for the rocket to reach the peak height? So your final velocity equal to your initial velocity plus the acceleration times time. You fill in your numbers and you're going to get 6.0 seconds when you solve for time. You have a negative value there because of the way the rocket is moving. B says, what is the initial time of flight in the model rocket? If we ignore air resistance, the time on the way down will be the same as the time up, so the total time of flight will be 12 seconds. And what is the peak height on the rocket from ground? So you would have your final velocity squared equals your initial velocity squared plus 2 times your acceleration times your distance. And so then when you solve for distance on that one, you would get 176.4 meters. So 4 says in a class experiment, determine information about free fall acceleration. A watermelon and a pumpkin are each set to fall from the back of a stand at your football stadium. A, if the watermelon and the pumpkin are both dropped at the same time, which one will hit the ground first? And they will hit the ground at the same time because they have the same initial velocity, the same acceleration, and the same vertical distance to the ground. If the watermelon is thrown downward with an initial speed of 10 meters per second and the pumpkin is dropped, which one will be at the ground first? The watermelon will hit the ground first because it has the initial velocity downward. If it takes the watermelon 1 second to reach the ground when it's thrown downward at 10 meters per second, how tall are the stands? So you're going to take distance equals initial velocity times times plus 1/2 acceleration times time squared, and you're going to get the distance to be 14.9 meters. And D, how long does it take the pumpkin to reach the ground if it is dropped from this height? So D equals the initial velocity times time plus 1/2 acceleration times time squared. So that calculation will give you 1.74 seconds. All right, I hope this helps. If you have any questions, log on and talk to me.